In this problem, we are going to compare the values of e to the power of pi and pi to the power of e without using a calculator. So to approach this problem, first of all, we can draw a graph of y equals to 1 over x, which is a hyperbola, because we know that the hyperbola, the area under the curve of the hyperbola, is going to use definite integrals, and we can then plot the points e and pi and observe the area to compare the two values. So first, we can draw the hyperbola y equals to 1 over x. And then we can locate the x coordinates e and pi. E is approximately 2.71 and pi is 3.14. So we will know that pi is greater than e. So we can let this part equals to e and this point equal to pi. Then we can draw the area under the curve, which will look like here. So the area under the curve here is going to be a definite integral. So we can write this as pi e, the integral of pi and e, and then write the function 1 over x times dx, where d is a derivative of x. So this is going to be the area under the curve, written in the form of definite integral. And then we can observe e and x. Well, the area under the curve seems to be cut out from the rectangle formed bound by the distance e to pi. And then to complete the rectangle, we can just fill this portion out. To find the area of this rectangle, well, we know that the width of this rectangle is going to be pi minus e. And then the y coordinate is going to be the length of the height, or the length of the rectangle. And this will be 1 over e. So the y coordinate would be 1 over e, because this is on the graph of y equals to 1 over x, and in this case, the x coordinate is e. And then we know that the area under the curve is less than the area of the rectangle. So it'll be less than 1 over e times pi minus e. And then we can apply the fundamental theorem of calculus to get that the area of the curve can also be written as the natural logarithm, which is basically ln, or log base e, of pi, which is the upper bound, minus 1. So we'll have ln of pi minus 1 is going to be less than pi over e minus 1. So minus 1 cancels out. You'll have ln of pi less than pi over e. We can remove the denominator by times both sides by e. So we have e times ln pi is less than pi. Then we can apply a property of logarithms. So we can move the coefficient into the exponent of the base of the logarithm, of the argument of the logarithm. So this will become ln of pi to the power of e is less than pi. And then we can apply a property of the log, meaning that since this is log base e, this will become pi to the power of e is less than e to the power of pi, because we know that we can rewrite log as basically the inverse of exponents. So that is how we got this. So the answer to this problem is going to be e to the power of pi is greater than pi to the power of e. And that is how you solve this problem.